Hello everyone, welcome to another video. In today's video we're going to be doing the O levels 2022. This will be paper 2, so this will be the entire walkthrough, so it's going to be a long video, so let's go. So the first question, for first question is always going to be a full algebra question. So you can see that this is actually quite simple. I have the denominator 3 and 7. I just got to change it both to 21, so times 3 times 3 times 21. Okay, so basically after you do that, you can cross multiply and you get a 21 here, and then from there you just do the normal solving, and you can, then that's it. Okay, so for this one, this is sort of indices, right? So we need to change this to times first, because when it's divide, you cannot cancel things. So I'm going to change to times, and then these two will change places. And then you look, what I'm doing is basically the numerator is cancelling the denominator. So numerator, denominator cancel. For the A is the same, so numerator, denominator, and so on. So I'm just cancelling things, just like how you would do normally, and then I get the final answer. Okay, so next one, we are doing completing the square, right? So it's completing the square. So so we start from here. This working is a bit fast, so I'm going to do an extra step here. So we always have this plus bracket square minus bracket square. You notice that these three terms are still here. So these three terms are still here. I'm adding a dummy plus minus, so you plus and you minus, nothing happens, right? So what is inside the bracket? The bracket will always be the x coordinate divided by 2. Okay, and these three terms are going to become the perfect square, so to speak, and then it's going to be always x and this number here. If it's negative, then it's minus. Okay, then the other two terms are here. You can see that they are here. So you press calculator, these two terms just shift to the other side, and then at this stage is 145 over 4. Then you're going to square root both sides. So this one becomes plus minus square root, and then over here the square disappears. And then I'm going to shift the 9 over 2 to the other side to be negative 9 over 2, negative 9 over 2. So both are negative 9 over 2, and then you just press calculator. Okay, so that's how you do it. So the last part of this algebra question is actually pretty hard. I feel that it is considered quite hard. Basically, when it comes to simplify, you must know that simplify means what? You factorize everything, and then you should be expecting to cancel things. Okay, so factorize everything. So the numerator can be factorized by grouping. The denominator can be factorized by, if you take the 3 out first, you are left with 3 x squared and 4a squared. So actually you're using a squared minus b squared. So to see it clearly, you do the top part first. You're going to, from this 2, you take out the 4 and the x, you're left with here. This one you take out the 3, that's all. So take out negative 3, inside become like that. So be careful, it's always good to times back to check whether you get back these 2. And then below, for the denominator, you take out 3, you are looking at this. So actually this is just x squared minus 2a squared. So this 4a squared can be written as 2a bracket square. So that is your a and b. That's why the next step will be a plus b, a minus b. And then you realize that at this point, so from the top you also combine. So it's 4 minus 3 times x minus 2a. So that's how this came about. And then the below, after you do the a square minus b square, here you get this. Then you see that, oh, the x minus a can be cancelled away. So once you cancel something, it's most likely that you're already correct. So after that, you're just clearing it up and just writing the final answer. Okay, so for the second question, so this is some sort of interest question, right? So you need to pay attention. This is simple and compound. So one person is simple, the other one is compound. Be very careful. So they're asking you why account B is a better choice. So basically the one that gives you more money is the better choice. So actually, you don't even know compound interest is better, because compound is you take into account the previous interest, you give you extra. But in this case, you need to show working, no choice. So what you do is you count, you let the starting amount be p. You cannot use any number. If you use a specific number, you're only showing that, let's say you use 1000. You're only showing that 1000 is true to use compound interest. What about 1001? What about 999? What about 0? What about 200? What about 300? You cannot prove for all the numbers in the world, so you let it be p, some number, and then you put it into the simple interest. So 1% means what? 1 over 100, and then 5 years you times 5, so that is the interest. So it's 0.05 of your starting. And then you do the same thing for compounds. So compound, you do this, and then this is our standard formula, right? Then what you do is you minus p again, because this formula gives you the total amount of the 5 years. You still got to minus away the p to get the interest, and then you can see that actually it's 0.051 something. So the compound interest clearly gives slightly more, and that is the choice. Okay, so account B is the choice because it gives more. Okay, so the next question, again, be very careful. This is simple interest. Okay, so they say 1.8 per year. He leaves the money there for 6 years. At the end of 6 years, there is 1385. So ask you to find the starting amount. So the interest, okay, so the interest is 1.8, so that's why I have 1.8 over 100, and then 6 years, 6, and then times the p, because p is the starting amount. Okay, so this is the interest, and then I need to plus the starting amount to get the final amount. So it's 1385. So it's the starting plus the interest, and then from there you are solving equation. So what you can do is you can actually press this in the calculator. This is some number, then plus 1, right? So you get this number, you divide over, done. Okay, next one. So we are some sort of this is compound interest now, right? So this one 1.2, 4 years. At the end of 4 years, there is 4719 blah blah blah, and ask you to find what the total amount of interest earned over the 4 years. So they want interest. So if you put into the formula, this is just basic, just subbing into formula. So the interest go here, the year go here, the p go here, equal to the final amount here. You work backwards. So what you do is you can actually calculate this number in the calculator and divide over, and then you get your answer. But this p is the starting amount. Be careful. I want total interest, so you need to take this starting amount, this p, minus away the total. So this one is the total, and then minus the starting, which is 4500 point something, and then this 200 plus actually the interest earned over the 4 years. Okay, so it's a lot of English. It's more English than maths, to be honest. Okay, so it's a bit blur. Okay, so now we have another situation here. This is some driving, some hiring car, and then drive a total of 7 plus click, and then the car uses 5.8 liters per 100 km. This how much to hire the car. The fuel cost this much per liter. You know, this is all in euros, huh? Okay, and then she used her credit card, charge 1.5% extra because they convert to Sing dollars, and then this is the exchange rate. So a lot of info here. So exactly what on earth do they want at the end? So they calculate the total amount, including the credit card fee, blah blah blah, everything in Sing dollar. Okay, so there's a lot of things. So we got the fuel, we got the actual cost of hiring the car. So that's the two main bulk. So the car is 134.50. That's clear cut, right? So the total amount at the end, see, is the car, and we need to plus the fuel. So the fuel is the one that requires some sort of calculation. So the car uses fuel at 5.8 liters per 100 km. But did he travel 100 km? No, he traveled 700 plus. So we do primary school maths. So if 100 km use 5.8, I'm going to divide by 100 to get 1 km, and then I'm going to times 700 km because I traveled 700. So this is the amount of liter used. But how much does this amount of liter cost? Okay, so you're going to use this one, 1.52 per liter. Okay, so 1 liter is 1.52, 43 something times lah. So that's the cost. If you add them up, you are getting 200 plus euros. So what am I doing here? I'm dividing by 0.6 to get Sing dollar. How does it work? Because from the exchange rate is $1 to 0.66, right? So here. So I need to count 1 euros is how much. So from here to here, I divide by 0.6. So from here to here, I also divide by 0.6. That's why it's this. That's why you see I'm actually taking the number divided by 0.6 here to get your Sing dollar. Okay, so once I get a Sing dollar, I'm still not done because I need to pay the extra where 1.5% extra for the credit card. So 1.5 is just basically just divide by 100 times 101.15. So it's divided by 100 times this, and then that's it. So that's your final answer. What a long story. Okay, so for question 3, these are our giveaway cumulative. Okay, so you notice this is a percentage cumulative. It's a bit strange. Usually they give frequency, but they give you in percentage. So it's from 0 to 100. And then this is the so-called, over here, the x-axis is the age. Okay, and you see the good practice here. I always calculate 1 square how many. So from here to here is 5 square. And 1 square is 2. So from here to here is also 5 square and it's 10. So it happens to be the same. So one little box is 2. So it's good to know that. Okay, so I want the median for Singapore. So be careful, there's 2 graphs here. Singapore is the solid line. So median is always 50%. If I go here, you can see that it's somewhere here, right? So it's 40 plus 1 box. So 1 box is half a box, sorry. So it's 41. And then I want what percentage of the UK population, UK, not Singapore, and it's above 60. Above is over 60 is a bit tricky because I want the number on top. So what I do is I need to find the 60 years old first. So I come here, 60 years old, I want UK. So UK is the dotted line. I go all the way up, 60 is here. So I go all the way here, it's here. So it's 80 minus 2 boxes, so it's 76. But 76 is not the number because 76 is the number of people who are below 60. I want above, so I need to go up. So actually it's 100 minus the 76. So there's actually only 24%. So a bit tricky here. And then now I want what? 80 percentile for Singapore. So Singapore, 80% is here. Singapore is the solid line, so I go until the solid line here. You can see that it's half a box. Okay, from this number you add half a box, so it's 61. Okay, so it's 61, that's correct. So next one, they tell you the Singapore population is 4.03 million. Estimate the number of people aged under 25. So under is under, so it's a friendly one, no tricks. So the question is under 25 is how many percent of the population. We need to go for and look for age 25. So I'm back to the cumulative. I'm looking for age 25 somewhere here, right? 2.5 boxes. I want Singapore. So Singapore is a solid line. So I go up here, solid line, here. So it is 30 minus 1.5 box, so it's minus 3, so it's 27. So 27% of the Singapore population is under 27, under 25. So it's 27% is here, and times 4.03 million. So it's actually 4.03 times 10 to the power 6, 6 zeros, and then that's the answer. Okay. Next one, they tell you, they tell us the age range is the same. I don't know what's that for actually. And then they tell you to make two more comparisons. Now, in any standard deviation or cumulative kind of question, they ask you to compare. It's always going to be median and interquartile range. If the question is a mean and standard deviation, then you use mean and standard deviation. There's no standard one. You always compare these two things. So you know that I need to compare between Singapore and UK, right? So our target is to get this table out. So Singapore, what's the median? What's the interquartile range? UK, what's the median? What's the interquartile range? And then it's all standard work. So it's Q2 is 50%, Q1 is 25%, Q3 is 75%. So I'm just going to do one for Singapore, okay? So for Singapore, you can see that I found it already because it's at 50%. You go to Singapore, you go down. So the Q3 will be 75. 75 will be 2.5 box here. You come here, then you go down. So for 25 is here, you come here, you go down. So all these numbers here are the median, are the quarters. And to find interquartile range, you can see that I'm taking the Q3 minus Q1, 34. So 34 is here, right? Singapore, interquartile range. I do the same thing for UK, 38. And then this one I found already. So UK, you need to find your own median, which is 50%. And then from these four numbers, you're going to compare. I'm going to compare median. So with the median, it's always about who older, who faster, who cleverer, who score more marks, whatever, right? So this is the Singapore is older because the median is higher. And then for interquartile range, it's always going to be, the keyword is consistency. So the lower the better, right? Because it varies how much you vary away from the mean in some sense. Okay, so in this case, Singapore is smaller, so Singapore is more consistent. So you can see that in the answer, Singapore population older because the median is higher. You can say that it's slightly older because the median is higher. That's also can. And then you can see that the Singapore population is more consistent because the inter-quota range is lower. That's it, standard. Okay, so next question, we are looking at the big graph question. So as always, the free mark is always the first mark. So they give you this blank, you need to sub -4 in. So it's -4 into here and here. Just be careful that it needs to be bracket -4 cube. Because if this power is even and you just press without bracket, you're going to get it wrong. Okay, so this one. Then after that, you can see that this is quite generous. Usually they give 2, but this one I think the curve is quite hard to draw, they give 3. So you basically just plot everything, you just join it nicely. So that's your 3 marks. Okay, next thing, so this is where the hard part begins. So they say that, okay, this equation equal to x has 2 solutions. So the first thing I check is this the graph I draw? So I need to look at this, I flip back, I check. Okay, exactly the same, right? This is exactly the graph that I drew. So basically, this equation means what? This graph that I drew is going to intersect this graph. This graph is what? Y equal to k, y equal to a number. So it's y equal to 3, y equal to 4, y equal to 5, whatever, right? So it's a horizontal line. And then this has 2 solutions. So basically, this line, this horizontal line, and my graph should cut twice. So let's look at the graph. And this is where I take my ruler. Okay, so this is my graph. I'm supposed to have some horizontal line, and I'm going to cut the graph only twice. So I just anyhow put somewhere like that. Okay, so this ruler cuts my graph 1, 2, 3. Cannot, I need 2 times only. So let's go higher. So if I go higher, you notice that it only cuts once. So where on earth does it cut twice? Actually, it's here. When it's at the top, just at the turning point, just nice. It's going to cut 1 time here, 1 time here. So that's one answer. So this value here is actually the answer. Okay. Okay, so or rather this is the actual k value. Okay, because they ask for k value. And then the other one will be the same thing, same concept, but it's below. So this will be the one. And at this point, this is the k value I'm talking about here. So it's negative 1 point something, and over here is about 3 point something. And that's why the answer is 3 point something, negative 1 point something. So it's the place where it cuts twice. So this is very concept, this is concept heavy. So the average people who have no concept cannot do this question. Okay, so next thing is, this is even harder. So they ask you to draw a suitable line to solve this equation. And when you say draw a suitable line, that means you need to use your graph. So what I do is, I need to make your graph or my graph appear. And I like to write down the formula of my graph here. So basically, I start at the equation they want me to solve. And I must do something to this to make this appear. Now, it looks totally off, right? But the trick here is we always try to match the highest power. So x cubed is the highest power. In our graph, x cubed is also the highest power. So now, what do I need to do to change this 2 cube to cube over 5? The secret here is divided by 10. Because you see, if you do divided by 10, and you sort of cancel it out, you're left with x cubed over 5. You got it. So the whole thing should divide by 10. That's why you see I times the 1 over 10 here. Actually, it's not needed. Okay, so you divide by 10, you get this. This one, you divide by 10, you get 2.5, right? 2.5 can be written as 5 over 2. And then divide by 10, 2. 0 divided by 10, still 0, not 1. So at this point, I've already balanced the x cubed over 5. So these two are still not there yet. So this is negative 2.5. This is negative 2. What I do is I need to plus another half to get it to minus 2, right? So this 2, I need to be 1. So I need to minus 1. So the next step is actually both sides need to plus half a x and minus 1. So once you do that, the left hand side becomes exactly this, your graph. The right hand side, you plus this half x minus 1, you get half x minus 1. So at this point, our equation looks like this. So to solve this equation, I need to draw my graph, which I've drawn already, and I need to draw this line. Y equal this one, half x minus 1. So to get here, you are already quite good already. Then the question is how to draw. Don't need to ask me how to draw. Just plot 3 points. People ask me which value to choose. Anything also can. So just use some common sense. Look at your graph. It ranges from -4 to 4, right? I will just pick 0, 1, 2. Because my math's lousy, right? I wouldn't want to choose -4 in this case. My math's lousy. I'm just going to put 0, 1, 2. And I get 3 points. I plot the 3 points, and you notice that you will draw this line here. And what's the final answer? Is where the graph and this line will cut. You notice it cuts here, cuts here, cuts here. So the answer is not here, it's the x value. So it cuts here, x value. Cuts here, x value. So that's why this 1, 2, 3x value is the final answer. Like that from the graph. Okay. So I'm going to stop here. We're going to do for part 2 later.